Hi. Today we are going to talk about advancing personalized learning using robotics for people with autism. Advancing personalized learning is one of the 14 grand challenges posed by the National Academy of Engineers and was introduced to USC by Dean Yortzos, who has been an integral part of the National Grand Challenges program as well as starting the Grand Challenges Scholars Program at the USCViterbi School of Engineering. As students at Viterbi, we have access to many different resources including the undergraduate fabrication lab and the wealth of combined knowledge in the faculty and student body of USC as a whole. We plan on using these resources to design, develop, and build our robot to what it needs to be. Although autism seems like a small percentage of the population, 1 in 68 children being born in the U.S. are diagnosed with autism. The current education system does not have what we believe to be sufficient one-on-one focus for these students who have issues in social settings. The best-case scenario for an autistic child in today's American society is to have an aide while they are at school who leaves them after the school day is over. But we believe that this assistance needs to be there 24 hours a day, 7 days a week. And a robot is a perfect substitute. Even though people may argue that having a robot following a student around may create social barriers, having an aide has already caused these problems, so even though this robot will not be the perfect solution for social and academic integration for autistic students, it is a step in the right direction. The robot will be an adapting system, always taking in and processing data through our servers and data centers, changing its internal settings to match the specific student's needs. These profiles for the robot will be based on information to be gathered from USC Psychology Department, where many faculty members are leaders in child development and education. Our robot itself will be first prototyped using a Robots Create platform due to its open source community as well as ease of access, and then eventually develop into our own proprietary hardware. The software will be designed with ROS and C++ components depending on functionality. Again, because of our experience and background as well as a significant community of users. In order to identify the level of autism, we will use Professor Simon Baron-Cohen's autism test, and the software will self-adjust, giving each student exactly what they need. The reason we need to do this is because autistic children can grow up to do brilliant things and we need to give them all the resources that they will need to do so. Now we can listen to a great example of the abundant skills that many autistic people possess, told by Professor Simon Baron-Cohen.
Gary McKinnon, he came to our clinic in Cambridge. He has Asperger's syndrome. Many of you know that his autism led him to obsessively hack into the computers in the Pentagon. He did this not because he's a terrorist or a dangerous criminal. He simply thought that the Pentagon computers contained information that was in the best interest of the public to expose. He even left post-it notes on the Pentagon computer telling them that their security was poor. People like Gary don't deserve to be punished for the mistakes that they've made. Their autism left them socially naive and vulnerable, but people like Gary, many people with Asperger's syndrome, are unemployed, and we should be thinking about how to find them jobs so that they can feel valued and feel supported. Autism is teaching us about the minds of scientists, but minds wired for science are making us rethink the nature of autism. Thank you.
Professor Materik's research is aimed at endowing robots with the ability to help people, especially those with special needs. She works closely with Professor Brian Scassellati from Yale University and Cynthia Breazeal from MIT. Now hear Professor Scassellati speak of the goals of their research.
Robots today operate under very limited conditions. They work in the laboratory under very carefully controlled situations. What we want to do is we want to move these robots out of the laboratory and into schools and homes and clinics, places where we can directly help children on a day-to-day basis.
Hello. My name is Bandit. As you can see, I am a robot. We are now in the lab of Professor Myla Tarak at the University of Southern California. Her lab specializes in robots that help people. We are called socially assistive robots.
The group's first goal is to develop computational models of the dynamics of social interaction so that robots can automatically detect, analyze, and influence agency, intention, and other social interaction primitives in dynamic environments. So far, the lab has been able to develop a robot that responds to movement. Second, the expedition will develop machine learning algorithms that adapt and personalize interactions to individuals. Finally, the expedition will develop systems that guide children towards specific learning goals over periods of weeks and months, allowing for truly long-term guidance and support.
Thanks so much for watching and fight on!